Hi, my name is Tushar Mehta, and for this year's Congressional App Challenge, I return with PulmoAID. The purpose of my app is a web app available on all platforms, and it is identifying lung tumors or nodules efficiently to advance early detection. And the audience of this app is pretty much everyone, ranging from patients and researchers to pulmonologists and radiologists. Now you might be asking yourself, why lung cancer? Lung cancer is the second deadliest cancer worldwide, with a mortality rate between 80 and 90%. In order to reduce that, we focus on early detection so the nodules do not expand, but that's still not enough because in third world regions, there is a shortage of radiologists, and the response time between CT scans when they're taken and when they come back can be between 2 to 4 weeks. In addition to that, there's a significant amount of false diagnosis, which can range between 10 and 30%. PulmoAID addresses this through AI-driven disease diagnosis, which not only reduces the time but makes it almost instantaneous. In addition to that, it uses a multimodal approach, which not only looks at the CT scans but uses a holistic view to get a good interpretation of the patient's history as well as their family's history. The dataset used was from the National Institute of Health, had 53,000 participants and around 200,000 images. The methodology behind each patient's file is a simple four-step process. First, you take the 3D file and condense it into 2D slices. Then you train each of these slices using transfer learning and extract features. You combine those image features with the text-based features of the patient's and family's history, and use a binary classifier to get a final output of whether the region has a tumor or not. Finally, we used explainability methodologies to give both visual and textual-based interpretations. The results are simple. When only the CT features were involved, the model only performed with a 62% F1 score, but when combining the CT features with the clinical features, the model increased the F1 score to around 88%. Here is a sample workflow of the backend, along with a full architecture of the app, along with inputs and outputs. In summary, PulmoAID works as a digital radiologist, especially in third world regions, and enhances precision medicine. Finally, for the part that we've been waiting for, the demonstration of the app. So on the first tab here is the information tab, which is a summary of the things that I've been talking about. And on the left sidebar, the user can see their name as well as the date and time. The next tab on the right side is going to be the uploads and the inputs, which is going to be the CT scan as well as the demographic and clinical data. In addition to that, the doctors and patients can upload any notes that they want to be included in the input. The next tab to the right is going to be the output, so that's going to be the prediction in terms of a probability, as well as the explainability, which includes a shot plot and feature explainability plots. The next tab is going to be the patient's history of previous scans that they've uploaded, and then the next tab is going to be the interpretability with the patients can have a conversation. The last one's going to be the metadata to get information on the inputs, and lastly, the login screen. Thank you.